At Blackbook, we worked on a project recently with a large water utility client who was targeting the use case of predicting the risk of failure in their water main assets in particular. So with any machine learning project, the first issue is finding a clean and reliable data set to be able to train a model. In this case, because we were predicting failures, we needed as many example failures from the past to be able to train a model. Now, there was an issue that they had where these failures in the past were entered into their system incorrectly, and so it left us with an unreliable data set. So as an example, if you can think of me as a water utility customer, I open my front door, I see a huge puddle in the street, and I think, hey look, I think the water main's burst. I call up my provider, I say there's been a water main burst at this address. The call center operator then sees, okay, this is the closest water main to that address, and assigns that to a particular work order, which is then sent off to a contractor. The contractor then goes and fixes the issue, but while they're fixing it, they realize actually this isn't a water main that's failed, it's actually the smaller pipe that comes off the water main called the water service. So they enter that into the notes, and then they head home and the work order is closed or is completed. Now, the issue there is that the original asset that was attributed to that work order, the water main, has actually now been there's now false data in there claiming that that has actually failed in the past. And so as you can imagine, that amounts to not a clean, reliable data set that we need to be able to train a machine learning model. What we found is that the notes written by the contractor were descriptive enough that it was reasonably obvious whether or not the issue was relating to a water main or a water service. So we decided to train a machine learning model to classify the asset type of a work order based on these notes, and we were actually able to hit slightly above 95% accuracy. We then took this classifier, ran it over the entire historical work order archive, in effect cleaning this data, and we were able to then confidently pull a data set to train our prediction model, which also ended up being a success. So this really goes to show that it's not the end model that you can only apply machine learning to. If you're trying to clean data in preparation for that step, you can also use machine learning.